All right, so today we're diving into something pretty cool, something we all do naturally, but probably don't think too much about.
Hmm. Sounds intriguing. I'm all ears.
It's all about learning from examples.
Hmm.
Like how many times have you learned something new fastest by actually seeing someone do it first?
Oh, yeah. Tons of times for sure. Whether it's like a new recipe or a DIY project, watching someone else just makes it click.
Exactly. And even in more academic stuff, sometimes seeing a problem completely worked out helps way more than just struggling with it yourself, right?
Totally. And that's actually what we're going to unpack in this deep dive.
Right.
Why learning from examples is so powerful, the science behind it.
Right. And not just why it works, but also what kinds of things are best learned this way. And are there different kinds of learners who really benefit?
Definitely. We'll dig into all that. And to guide us, we've got this awesome 2010 research paper by Tamar Van Gogh and Nicole Rummel. It's called Example-Based Learning, Integrating Cognitive and Social Cognitive Research Perspectives.
So a pretty comprehensive look at the whole thing.
Yeah, they pulled together a lot of research, different perspectives, really fascinating stuff.
Okay, so let's get into it. Why do examples work so well for learning?
Well, let's start with those step-by-step solutions, what researchers call worked examples. There's this well-known phenomenon called the worked example effect, and it's pretty counterintuitive.
How so?
Well, you'd think that struggling with a problem yourself would lead to better learning, right? But it turns out, especially for novices, for beginners, studying a worked example is often way more efficient and effective.
Hmm. So just seeing the answer laid out can actually be better than trying to figure it out yourself.
In many cases, yes, and it comes down to how our brains work, how we approach problem solving when we're new to something.
Okay, I'm curious. What's the typical approach?
A lot of times, new learners use what's called means-ends analysis. So they focus on the difference between where they are now and the goal, and they try anything that seems like it might get them closer.
So a bit of a trial and error process.
Yeah, and while it can work, it can also be really inefficient. You're kind of overloading your working memory, and you might not be focusing on the most important parts of the process.
Makes sense. Like trying to navigate a new city without a map. You might eventually get there, but
Exactly. You're not really building a mental map, a schema for how to get around. And that's what worked examples do so well. They help you build those cognitive schemas, those mental frameworks for solving problems.
so by seeing the whole process laid out, you start to understand the underlying structure.
Exactly. It's like having a blueprint or a template. And research shows that studying worked examples can act like analogies. So you can consciously or unconsciously draw on those examples when faced with a new, similar problem.
Oh, that's interesting. So it's not just about memorizing the solution to one specific problem.
No, it's about extracting general principles, strategies that can be applied to other problems, even ones that look different on the surface.
Cool. Now, I can imagine some people saying, well, of course, worked examples look good if you compare them to just throwing someone in the deep end with no help at all.
Right, that's a valid point. But studies have shown that even in situations where learners are getting support, like tutoring or realistic classroom settings, adding worked examples on top of that still improves learning.
So it's not just that they're better than nothing. They're actually better than other common methods.
Yeah, research has consistently shown that. They can be more effective than discovery learning, where you figure everything out yourself, and even more effective than problem solving with just some general guidance.
Okay, so worked examples definitely have their place. What about those other types of examples, the ones where we learn by watching someone else do something?
Those are called modeling examples. And the way they work is really fascinating. It's all about observational learning, a big area of research in social cognitive theory, particularly Albert Bandura's work.
Oh yeah, Bandura. He did a lot of work on how we learn by watching others,
Yeah.
right?
Exactly. And the core idea is that when you watch someone perform a task, you're not just mimicking their actions, you're creating a mental representation, an internal model of what they're doing. And that mental model is what allows you to reproduce the behavior later, even when the person you observed isn't there.
Hmm. So there's a cognitive process going on, not just mindless imitation.
Right. And Bandura outlines a few key elements for this to work. First, you got to pay attention. You need to focus on the important parts of what the model is doing.
Okay, attention. What else?
Then comes retention. You need to be able to store that information in your memory, but it's not just passive recording. You're actively organizing it, connecting it to what you already know.
Right, like creating those mental schemas again.
Exactly. And this is where things like mental rehearsal come in, running through the steps in your head, maybe even physically practicing.
Makes sense. So attention, retention,
Hmm.
What else?
The next step is motor reproduction, but this only applies if the skill is physical. Can you actually do what you observed? And finally, there's motivation. You might have learned something perfectly well by watching, but you're not going to do it unless you're motivated to.
Right, so you need to want to use what you've learned. So we've got attention, retention, motor reproduction, and motivation.
Got it. Now, you mentioned earlier that there might be a difference in how we pay attention with worked versus modeling examples.
Yeah, that's a key point. Think about it. A worked example is usually very clean, just the essential steps, often in text form.
Right, very focused.
Exactly. Minimal distractions.
Yep.
But a modeling example, whether it's someone in person, a video, or even an animation, can have a lot more going on visually.
Oh, yeah, for sure. You might be paying attention to how they look, their tone of voice, the environment.
All those things.
Yeah.
And even if the model is trying to be clear, they might make mistakes, especially if they're not an expert themselves. So worked examples are kind of like learning from a perfect textbook, while modeling examples are more like watching someone figure things out in the real world.
That's a great analogy. So we've got a good handle on why example-based learning works. Now let's shift gears. What kinds of tasks, what kinds of skills are best suited for this type of learning?
Yeah, I'm curious about that.
Traditionally, worked examples have been the go-to for structured cognitive tasks. Think like math, statistics, physics, geometry, the kind of problems with clear steps and usually one right answer.
Ooh, the stuff I used to dread in school, the ones with formulas and all that.
Yeah, exactly those.
Yeah.
But what's really interesting is that more recent research has found that worked examples can be effective for less structured tasks as well.
Really? Like what?
Well, think about something like instructional design, creating learning materials, or argumentation skills, developing a strong argument, or even something like concept mapping or recognizing different artistic styles.
Wow, I wouldn't have thought of using a worked example for something as open-ended as, like, analyzing a painting.
Right. But it turns out they can provide a helpful framework, a starting point for approaching these more complex tasks.
Fascinating. How about modeling examples? What are they best for?
Modeling examples are also used for those structured skills, like math, sometimes with a focus on boosting learners' confidence. But they're often more effective for things that are less structured, more social, or involve physical movement.
So things like writing, communication skills, teamwork, stuff like that.
Exactly. Things where you benefit from seeing how someone else navigates those situations.
It's like learning by watching a pro, seeing how they handle those tricky moments.
Yeah, and it goes beyond that. Modeling examples have even been used effectively to teach metacognitive skills. Things like how to regulate your own learning, how to monitor your progress. And they've also been successful with psychomotor skills, those involving physical movement.
Oh, interesting. That makes me think of those mirror neurons in the brain.
Yeah, the ones that fire both when you do something and when you watch someone else do the same thing.
Exactly. So is there a connection there?
It's definitely an area of active research. We know those mirror neuron circuits are involved in motor learning, but could there be a similar mechanism at play for learning cognitive skills by watching others?
Like a cognitive mirror neuron system. That's a cool idea. Now, you mentioned collaborative learning earlier. How does example-based learning fit into that, in a learning in groups?
That's a good question. And the research is a bit mixed on this. Some studies suggest that for highly structured tasks, studying worked examples individually can actually be better than doing it as a group.
Oh, interesting. Why is that?
Well, the thinking is that worked examples already reduce the cognitive load, the mental effort, so individuals can process them effectively on their own, whereas for tasks that require more problem solving, having multiple perspectives might be more beneficial.
So if the solution is already laid out, too many cooks in the kitchen might actually make things more confusing.
Yeah, something like that. But on the other hand, observing modeling examples of group work, like watching a really effective team in action, can be really helpful for learning collaboration skills.
So the ideal approach depends on what you're trying to learn, how complex the task is.
Exactly. And researchers have also started looking at what they call double content examples, which teach both a topic and a skill, and even triple content examples, which add strategic knowledge.
Wow, so packing even more into those examples.
Yeah, but the key is to be mindful of cognitive load. When an example is trying to teach you multiple things at once, it can get overwhelming. It might be better to focus on just one aspect at a time.
Makes sense.
Yeah.
Don't try to bite off more than you can chew. So we know why examples work, what kinds of tasks they're good for. Now let's get to who benefits most from this kind of learning. Is it for everyone?
Well, with worked examples, research suggests they can be beneficial across all educational levels. But a really important factor is the learner's prior knowledge, what they already know.
Okay, so it's not one size fits all.
Right. This is where the expertise reversal effect comes in. Highly detailed, step-by-step examples are amazing for novices, for people who are completely new to a topic.
Yeah, they provide that structure, that guidance.
Exactly. But for people who already have some expertise, those same highly structured examples can actually be unhelpful.
Oh, interesting. Why is that?
They might feel too basic, too restrictive, like they're being spoon-fed when they're ready to apply what they know and explore more independently. So the level of guidance needs to match the learner's expertise.
Hmm. So it's about giving enough support, but not so much that it stifles learning.
Exactly. Another factor that seems to matter is working memory capacity. How much information you can hold in your mind at once.
Oh, right.
Since worked examples reduce cognitive load, they might be especially helpful for people with lower working memory capacity. And there's even some evidence that older adults might benefit more from example study than younger adults, possibly due to age-related changes in working memory.
So our individual cognitive differences can influence which learning methods work best for us.
Yeah, that seems to be the case. How about modeling examples? What do we know about who learns best from those?
Yeah, fill me in.
Modeling examples have been studied with a really wide range of learners, and they've been shown to be effective in lots of different contexts.
Like what?
Well, they've been used to encourage workplace safety, to help college students choose better memory strategies, even to improve writing and self-management skills in adults.
So applicable across the board.
Yeah, pretty much. And what's interesting is that they've even been effective with learners who have different cognitive profiles. For example, peer modeling, using other students as models, has been found to be helpful for children with intellectual disabilities and autistic children.
That's cool. Maybe it's about seeing someone more like you succeed makes it feel more achievable.
That could be part of it. But just like with worked examples, prior knowledge plays a big role in how well you learn from modeling.
How so?
If the behavior being modeled is too complex, too far beyond what the learner already knows, it can lead to fragmented learning. They might not grasp the whole picture.
Makes sense.
And another potential pitfall is that novices might not recognize errors in the model's performance. They just don't have the knowledge base to know what's right and wrong.
Oh, so they could be learning the wrong way to do something without realizing it.
Exactly. And another big factor that's been studied a lot with modeling is self-efficacy, that belief in your own ability to do something.
Oh, yeah, that's crucial for any kind of learning, right?
Absolutely. And interestingly, the type of model you observe can actually influence your self-efficacy.
Really? How so?
Well, seeing someone you perceive as similar to you succeed can boost your confidence. But seeing someone who seems way more advanced might actually make you feel less confident.
That makes sense. So it's not just about finding the most skilled model, it's about finding one that's relatable and motivating for the learner.
Right. And researchers have also looked at other learner characteristics that might play a role, things like self-esteem, locus of control, even personality traits like extroversion.
Wow, so there's a whole interplay of individual factors that can affect how well you learn from examples.
Definitely. It's a complex picture, but it's fascinating, right?
Totally. So we've covered who benefits. Now let's get practical. How do we actually design effective examples, whether they're worked or modeling examples?
All right, let's dive into that. With worked examples, one of the key early findings was that just providing any old example wasn't enough.
Oh, so the design matters.
Hugely. Just slapping down a solution doesn't guarantee good learning. Two really important principles emerged early on. Avoid split attention and avoid redundancy.
Okay, break those down for me.
Split attention happens when you have related pieces of information that are separated physically. Like you have a diagram and the text explaining it is on a different page.
Oh yeah, I hate that. You're constantly flipping back and forth.
Right. It adds to the mental load. The solution is to integrate those elements, put them together visually. And redundancy is when you present the same information in multiple ways when only one is really needed.
Okay, so keep it concise, keep related information together, and don't repeat yourself unnecessarily.
Exactly. Those are good starting points. And then there are other techniques for making worked examples more effective, more engaging.
Like what?
Well, you can use partially completed examples, so learners have to fill in some steps themselves. Or you can make the sub-goals explicit, label them, highlight them visually. You can even compare different methods for solving the same type of problem.
So it's about making learners think more actively about the example, not just passively reading it.
Precisely. And the role of explanation is huge. Encouraging learners to explain the reasoning behind each step to themselves, if they can do it well, can be really powerful. And if not, providing clear instructional explanations can help, although those explanations might need to be gradually reduced as the learner gets it to avoid redundancy.
Right, they can become a crutch if you're not careful.
Mhm.
What about intentionally including errors in worked examples? Is that ever a good idea?
It can be. Using examples with errors and asking learners to find and correct them or giving them feedback on those errors can actually promote deeper processing.
Interesting. So learning from mistakes, even if they're someone else's, can be helpful. Now, switching to modeling example, what are the key design considerations there?
One big question is, how should the model behave? Should they present a perfect performance or should they be more natural, maybe make some mistakes and correct them?
Yeah, that's a good question.
The research on showing correct versus incorrect behavior has had mixed results, depending on the task and the learner's prior knowledge.
So no easy answers there.
Right. Another thing to consider is the impact of feedback. Just like in real life, feedback on the model's performance can influence what the observer learns. And brain research has shown that we have a similar neural response to our own errors and to observed errors, which suggests our brains are wired to learn from both.
That's pretty cool. Brings us back to those mirror neurons again.
It does. And then there's the imagination effect. For learners who already have some knowledge, mentally rehearsing the steps they've observed can really boost learning. But for complete novices, it can actually be detrimental.
So too much mental effort when you don't have the basics down yet.
Yeah, it can backfire. And remember, we talked about that goal-free effect. Well, that applies to example-based learning, too. Sometimes just observing someone solve a problem without having a specific goal in mind yourself can lead to better learning.
That's counterintuitive. You'd think having a clear goal would be essential.
You would, but it seems that not having that pressure to achieve a specific outcome can free up your attention to focus more on the process itself.
Fascinating. So any other unique design considerations for modeling examples?
Yeah, tons. One big one is model-observer similarity. You know, how similar the model is to the learner in terms of gender, age, perceived competence, background.
So who's doing the demonstrating really matters.
Absolutely. While the effects of gender similarity are mixed, age similarity, particularly using peer models, has been shown to be helpful for lower achieving students. And the model's perceived competence is crucial. While experts are generally good models, for comparison purposes, models who seem to be at a similar level as the learner can be more effective. And there's a difference between mastery models who perform perfectly and coping models who show some errors and how they correct them.
Oh, right, those coping models.
Yeah, some research suggests they can be more effective, especially for learners who identify with them, who see themselves at a similar skill level. And there's even evidence that weaker students might learn better from weaker models and stronger students from stronger models.
So it's not always about aspiring to be the best. Sometimes it's about seeing someone who's more relatable, struggle, and then overcome those struggles.
Exactly. And that brings us to what's called the paradox of expert models.
The paradox of expert models.
Yeah, so you'd think learning from the best would always be ideal. But experts often perform tasks so automatically that they skip steps, use jargon, and that can make it really hard for a novice to follow.
Oh, right, they're not breaking it down for someone who's just starting out.
Exactly. And while that high level of abstraction might be good for transfer, for applying the knowledge later, it can be really confusing initially. So there's a question of whether the model's expertise affects learning differently depending on the learner's expertise.
That's an interesting question. Is there any research on that?
There is. One study found that expert worked examples were actually better for physiotherapy students learning to take patient histories. Maybe because in that context, the expert streamlined approach was more beneficial.
Interesting. So it really depends on the specific situation, the interplay between the learner's expertise and the model's expertise. What about when the model is the learner themselves?
Oh, that's called self-modeling, and it's been found to be super effective. You know, you record someone doing the task, edit out the errors, and then they watch themselves performing it correctly.
Wow, that's cool. So you're essentially creating your own ideal model.
Precisely. And with all the screen recordings and animated agents being used these days, there are other design factors to consider. How similar the voice sounds in terms of gender and age, how competent the animated agent is perceived to be, all of that can affect learning.
Right, those virtual models are becoming more and more common.
They are. And those general principles for multimedia learning apply here too. Things like using a conversational style, a standard human voice,
Mhm.
and being mindful of whether showing the speaker's face is necessary or distracting. Research shows we tend to focus on faces, so if it's not adding crucial information, it might be better to leave it out.
So keep it clean, keep it focused.
Right. And with things like animations and screen recordings where information appears and disappears quickly, it's important to use cues to guide attention, like highlighting or showing where the model is looking. And breaking down complex examples into smaller chunks can be really helpful, especially for novices.
Okay, so a ton of design principles to keep in mind. Now let's talk about how we actually deliver these examples to optimize learning. What are the best strategies?
One key takeaway from both the cognitive and social cognitive research is to combine observation with practice.
So don't just watch, do it too.
Exactly. For modeling examples, giving learners a chance to practice right after observing can help them identify their own weaknesses and be more attentive during future observation.
Makes sense. You realize, oh, that part's harder than it looks.
Right. Now, with worked examples, a common approach has been to use example problem pairs. So you study a worked example, then try a similar problem yourself. And this has generally been found to be more effective than just problem solving alone, especially for learners with low prior knowledge.
But you mentioned earlier that there might be another side to that.
Yeah, there is. Some research has actually found that studying examples only can be more effective than problem solving. And a recent study showed no difference in learning outcomes between examples only and example problem pairs.
Interesting. So jumping straight into a problem after the example might not always be the best move.
Yeah, it's worth considering. What about trying the problem before seeing the example?
Yeah, what about those problem example pairs?
Those can be less effective for novices. They often lack the skills to diagnose their own errors, so just seeing the solution afterward might not be that helpful. But some studies suggest that learners with more prior knowledge might actually benefit more from problem example pairs.
So again, it comes back to that interplay between the learning method and the learner's expertise.
It does. And another really useful delivery strategy, especially for those cognitive tasks, is called fading.
Fading.
Yeah, you start with fully worked out examples and gradually increase the number of steps the learner has to complete themselves.
So slowly removing the scaffolding.
Exactly. And interestingly, backward fading, where you omit the later steps first, can be particularly effective.
That's cool. Like letting them figure out the end game first.
Yeah, sort of. And in motor learning, combining physical practice with observation has been shown to be better for transfer than practice alone. And the timing of the modeling seems to matter too. When you observe during your practice can influence how well you learn.
Makes sense. And finally, what about the order in which we present different types of examples or problems? Does that matter?
It does. Instead of blocking, grouping similar problems together, interleaving, presenting them in a random order can actually lead to better learning and transfer.
Really? Why is that?
Well, it makes you work harder during the learning process because you're constantly switching between different types of problems, which increases cognitive load. But that effort seems to pay off in the long run.
So a bit of desirable difficulty, like those challenging workouts that lead to better fitness.
Exactly. It forces you to compare different solution strategies, figure out which one is appropriate for each situation.
Wow, so we've covered a lot in this deep dive. What are some of the key takeaways for you?
Well, one big one is that both worked and modeling examples are incredibly powerful learning tools.
Yeah.
They both rely on this idea of building a mental representation, but they do it in different ways, with different formats for different types of tasks.
Right, and we saw that they both have their strengths and weaknesses, depending on the learner, the task, and the specific design choices.
Definitely. And it's not just about picking one or the other. The expertise reversal effect reminds us that we need to adapt the level of guidance as learners become more knowledgeable.
Yeah, what works for a beginner might not work for someone who's more advanced.
Exactly. And we saw that other factors like working memory capacity, even personality traits, can influence how well someone learns from examples.
And the design of those examples is crucial. Just throwing an example at someone isn't enough. You have to think carefully about how you present the information, how you engage the learner.
Absolutely. Things like avoiding split attention, minimizing redundancy, encouraging active processing, choosing the right kind of model, all of those details matter.
So it's not just about knowing that examples work. It's about knowing how to use them effectively.
And that's what this research helps us do. It gives us those evidence-based strategies for designing and delivering examples that really make a difference.
Totally. Now, one thing that struck me is that the research in this area, while extensive, is also quite nuanced.
Oh, yeah. There are definitely some seemingly contradictory findings.
Like those findings about weaker students learning better from weaker models, versus the idea that only learners with more prior knowledge benefit from seeing errors.
Right. Those are puzzles that researchers are still trying to solve. It highlights how complex learning is, how many factors are at play.
So it's not always about finding the one right answer. It's about understanding those nuances, those interactions between the learner, the task, and the example itself.
Exactly. And that's what makes this field so exciting. There's still so much to learn.
So here's a final thought for our listeners to ponder. How can you use both worked and modeling examples more strategically in your own learning? Thinking about what you already know, what you're trying to achieve, and those different design principles we talked about. Do you naturally gravitate toward one type of example? Maybe you should consider incorporating the other more often. And I think having this understanding, this awareness of how example-based learning works can give you a real advantage in your own learning journey.
I totally agree. And as we've seen, this integration of cognitive and social cognitive perspectives, especially with all the new technologies we have for creating and sharing examples, is opening up some really exciting possibilities for the future of learning design.
Well said. Thanks for diving deep with us today.
My pleasure. This was a great conversation.
Until next time.